Hi, I'm Jay, and I'm Debug Steven on Twitter if you'd like to follow me there. Today I'm going to talk about compiler errors by iterating over code examples and explaining how we got those errors and how to fix them. Over the last year, I've become friends with the glorious Glasgow Haskell compilation system. For this presentation, I'll be using GHC version 8.2.2. I started self-studying Haskell after I completed my bachelor's in computer science last year, and I started a Haskell book club here in Denver in August. We completed the entire book like 2 weeks ago. So I struggled along with my fellow attendees to get my Haskell code working, which meant reading the error messages and trying to figure out what they mean. Working with the Haskell compiler errors can be difficult because Haskell is a very different language from what most people are used to. But if you practice, like we'll do today, you'll be able to do it. And I'm hoping by the end of this talk, you'll have a better understanding of GHC's errors. Before we iterate through parse errors, definition errors, and type errors, I'd like to talk about how errors manifest in our programs and how we respond when we see those error messages. So, most of the errors we encounter when we program are type errors. These type errors can appear in different ways. In dynamic languages, for example, it's with runtime errors. One of the most useful tools in that instance is peppering your program with print statements to figure out where the error is occurring and why. That's not really efficient though, and there are several drawbacks. You can forget about your print statements later on. It's a slow feedback loop to figure out why your program isn't working, and it's subject to user error. In Haskell though, since we have types like bool, int, string, and so on, we have greater confidence about what we'll get out of our functions. The type signatures on our functions can help guide us to correct code, and GHC will use the types to help point out where we've gone wrong too. So, how do we typically respond when we see error messages? I generally get frustrated. I just want to solve this problem in my program and have my program compile. The compiler is holding me back by preventing me from getting a program to run. I feel bad about this red highlighted text that says, hey, you messed up here. And reading the error, thinking about like how Simon Payne Jones is like clearly disappointed in me for even like getting this error. So there's this human aspect to reading the text. I've definitely read the error messages in the voice of my mentors and have felt like not knowing how to fix it immediately or without thinking is a failing on my part. It isn't though, so consider this instead. So functional programming is like snapping a bunch of functions together to get the result you're looking for. This is like solving any sort of puzzle. Think about putting a jigsaw puzzle together. I personally have never gotten mad about putting a puzzle together. That's a pretty fun activity. So it's usually clear when two pieces don't fit together. So you just move on in your puzzle solving to get the puzzle completed. The error is unspoken and obvious just upon inspection of the attempt to put the incorrect pieces together. You don't usually like try to match the pieces together and decide that solves your problem instead. That piece goes somewhere else. So let's rethink our feelings about the compiler. So what if we had a puzzle referee, someone that told us our puzzle pieces aren't fitting together? It isn't always obvious looking at a program without compiling or running it that the code will or will not compile. So Haskell won't let you mash functions and types that don't go together because it is strongly and statically typed. We have greater confidence about what we will get out of those functions because the GHC referee enforces the rules for putting our program together. So we have to spend a little more time up front figuring out how to fix our errors, but in my opinion, this is significantly better than spending that time fixing your type errors when they're discovered at runtime. So GHC will tell you where the error occurred, what rule you broke, and what was expected by the compiler. This is super helpful. So you can read the error message and then fix your code to adhere to the rules. So let's celebrate getting compiler errors. They're saving us time from debugging errors later on. So now that we've talked about how to feel better about seeing error messages, let's talk about the kinds of errors we will encounter when we try to get our program working. Parse errors occur when we have broken a formatting rule or some convention enforced by the compiler. And once we get all of those fixed, we'll get definition errors. Definition errors occur when we are calling a function that isn't defined by us in the scope of our program, or the function hasn't been imported from another module yet. And after we fix our definition errors, we'll get type errors. Type errors occur when we've told the compiler we would do something via our types. We haven't followed through on that in our function. So after you fix all those errors, you'll get your program to run. So let's take a look at parse errors first. So I'm going to do some scrolling because this file is a little bit too long. So if there's something that you can't see on the screen that you think you should be able to see, please let me know. So here's our file. This does not work. We're going to talk about why this does not work. So let's try to load up this file. So the first error we're going to get here is a parse error on input module. So and we see that error occurs on line 5. So let's go look at the file, check that out. So there's line 5. That's where we're getting tripped up. So let's talk about the rules that we're breaking here at the top of the file. So, yes?
Would it be possible to change the contrast for the code set? Maybe we can turn off the light. Or you just turn off the light. I can't see.
Oh, okay. No, that's fine. Let's go back then. So, better? Cool. So that's where our error is happening. So parse error on input module. So at the top of the file, we're going to list our language pragmas at the top. And I personally like to have language in all capital letters just because I like to yell as much as possible in my code. And then if you decide to have a module name, it has to be declared above your imports and your functions. And it has to start with a capital letter. And then below your module name, you can have your imports that you want to use functions that you don't want to define yourself that someone has already written in a library. So let's look at how we can fix this. So we're just going to move module above our import. And so our commented out version there is what we had before. So now that we fixed that, we can move on and reload our file to see what our next error is. So the next error that we get here is parse error on input skinny arrow here on line 14. And so let's go check that out. So we're going to take a look at this entire code block here because there are similar problems. So the indentation rules. Code implementations have to start at least one space after the function name on the following line if that's where your implementation starts. And then the next one is, if you're making a new code block, you need to denote that by having that block at least one space over. And most people are using at least 2 spaces for readability, which is what I'm doing here. And so you can see here that true is indented 2 space over from case of. And generally you'll know you're making a new block because you'll be using a control structure of some sort. So inside of our code blocks, stuff has to be lined up. So specifically the error we were getting was that false was indented 2 spaces over. So we'll want to make sure that true and false line up because they're in the same code block. So here's our block adhering to our indentation rules that we just covered. And so that's what it was previously. So let's reload and take a look at our next error since we've fixed all of our indentation problems. So the next error we're going to get is parse error, possibly incorrect indentation or mismatched brackets. I promise I did not lie to you about not fixing all of our indentation problems. This error is occurring on line 19, and there's actually no line 19 in this file. So let's go look at the end of the file instead. So here's where we're getting this problem. Let's talk about why this doesn't work. So functions are top-level declarations. Everything in Haskell is a function. So in other languages, you might be used to using some keyword to say, hey, this is just a variable, to distinguish it from other like functions. But you don't need to do that in Haskell. Let and where just meant to define functions inside of other functions with a local scope. So if we just take off the let in front of that function and just like have it be a function name, that will be fine. So that's going to fix our problem there. So on to the next one. We've gotten rid of our let there, and that should be fine. Let's reload and see what our next problem here is. So we're seeing that the type signature for rule breaker lacks an accompanying binding, and that's occurring on line 10. So let's go look at line 10. And so you may notice here that there's a typo between the two. Yeah. So like reading that error for me for the first time was really difficult. I didn't really like understand what it was saying. So like if you have a type signature, like if you're getting that error, it's like, hey, you don't have an accompanying binding. You probably like just typoed it, or you haven't actually like created the function yet. So if you have a type signature, you have to have a function that like goes with that type signature. So if we just fix that, just fix the typo there, that will be fine. So let's reload, move on to the next one. So our next error here is that the IO action main is not defined in module main. So let's go look, see if that's true. So we do have a module main, and we have this function that's called myMain. So the rule here is that if you have a module main, you have to have a function that is called main. And if you don't want a function called main, just rename your module to anything else. So anything else that starts with a capital letter.
That only if it's an executable, or like declared as an executable. Or a test.
I'm just talking about just generic files. So we're just going to rename the function to main because it doesn't matter to me. Like, that's fine. So we'll rename that and we'll reload our function or file now. So we have two errors, but these go really well together, hand in hand. Let's see. So the first error says that we couldn't match the expected type of main, which is IO of something, with the actual type in the type signature that we gave it, int. And the compiler tells us on the second error, we told them that we would give them an int, and the type that we're actually providing here is IO of unit, and it actually points to the particular expression. So print hello world. Print has the type signature of A, where A has the constraint of being shown, to IO of unit. So it would make sense that that function would return IO of unit. So let's go look at those lines in the file. So that's where we're getting those two errors. And we did in fact say that we would return an int here, and we're not. So specifically created that type error so that it would tell us what type it was expecting instead. So that we could touch on the fact that if you have a function main, you actually have to return IO of some type. And most of the time, at least when I was starting off, you're going to return IO of unit. So we'll just fix that. We'll change the type signature to properly reflect what type we're giving back, and that's good. So now that we've done that, let's reload our file here, see that how everything is going. Perfect, we've done it. So there's just one more thing that we have to fix now. So if you were paying attention to the strings, I've changed them to properly reflect that our code is now working. Perfect. So now that we've covered parse errors, let's move on to our definition and type errors. So for this first example, I'm going to turn off the implicit prelude, and then if you're following along, like in your own REPL, I'll remind you to turn it back on afterwards. So the first error that we're going to look at here is module or define, which is a definition error. So to set up the problem a little bit, we're going to take a look at head. And head is a function that, given a list of some type A, it's going to return back to you the first element of that list. And if you pass it an empty list, it's going to blow up and say, hey, gave me an empty list, there's no first element to return. So here's the language extension to turn off the implicit prelude in the REPL. And so one of the first things that you're going to do when you're starting off with Haskell is write a safe head function. So a safe head here is, given a list of A, I might give you back an A if you have a list that actually has elements. So if you have an empty list, you're going to get back nothing. And we're going to talk a little bit about this second case here. So the first error that we're going to get here is that the type constructor maybe is not in scope in our type signature there. So we actually have to figure out where maybe is defined, and it is defined in the prelude, so you won't get this error if you still have that turned on. But I want to demonstrate how you would figure out where those things are defined. So we can use Google. We can search for maybe. So the first thing that you're going to see here is data maybe A, and this is the base and prelude. And we can import those, but I want to look at the module where this is actually defined. So I'm going to click on this link and we're going to check that out really quickly. So to import maybe, we would want to write import data.maybe, and let's take a look at the rest of this page just so that you can be familiar with Google. So we have the type constructor data maybe A up there, and then we have the data constructors nothing in just down below there. And so after that, we have the type class instances, and we have a whole bunch of functions that are defined in that module too. So we're just going to import data.maybe, and that will fix our problem with not having the type constructor maybe in scope. So we'll reload this file here, and we're going to get an error that says that head isn't in scope either. And so you can use Google again, and you'll find that that is defined in data.list. So let's talk about, we've fixed all of our definition errors at this point. Let's talk about how to resolve our remaining errors. So we're going to talk a little bit about how to use data constructors and type constructors. So the next error that we're going to get here is that perhaps you meant to use variable maybe imported from data.maybe. So you may have noticed that function in the module data.maybe, but that's not what we're really looking for here. Let's take a look at the data declaration for maybe. So the type constructor maybe takes one type argument A, and it has the data constructors nothing and just A, and that A is also a type argument that just takes. So you're going to use the type constructors in your type signatures, and you're going to use your data constructors in your function implementation. So we actually want to be using just here instead of maybe. So let's move on to the next error that we're going to get, which is too many arguments. So this is really long. If you'll recall from our data declaration of maybe, just takes one argument A, and it says here that we've applied just to two arguments, and it points to the particular expression just head x's. So in order to fix that, we just want to say this is one argument, and make sure that that reduces down to one value, and then wrap that value in a just. So that will work. That's great. So we're going to talk about another example of imports that I thought was just interesting. We're going to turn back on the prelude for the rest of the examples. So here we're just having a function alias for sort. And sort is just a function that takes a list and orders it. And so let's see what happens when we try to get this to compile. So we're going to get that the variable is not in scope sort, and that perhaps we meant square root, which, yeah, we didn't mean square root. But I just thought that that was really cool that GHC is going to suggest the closest name function that you have in scope. But yeah, not what we're looking for. You can use Google again to like figure out where sort is defined, but it's defined in data.list, and you can import the specific functions that you want by wrapping them in parentheses and then delimiting them by commas. So just want to import sort here, and that will work. So that's great. Let's move on to just type errors now. So we're going to talk about a type mismatch. To start off, we're going to talk about this type. So we have a type constructor called nat, and we have the data constructor 0, and we have successor, which takes one type argument nat. So this is a recursive way to build numbers, and the deriving equality and show at the end there just gives us a way to have equality and the ability to print out the data constructors for free. So a little background on this. This is called Pinot numbers, the way to represent numbers that I'm going to show you. And so that's pretty neat. So let's actually like look at this function. This was my first attempt at a function to take an integer and convert it to a natural number. So given an integer, you might get back a natural number. So we have our base cases up there, just 0 and just successor 0, just so that you can see like what that should look like. And given an argument I, if it's less than 0, it's not a natural number, so we're going to return back nothing. And then for the else, we want to say just successor and then maybe call the function again. Let's see what sort of error we get here. So it says that we couldn't match the expected type natural with actual type maybe natural in this particular argument expression here. So what would we expect this function to do if it could just run right now? So if we said integer to natural 3, it would give us back just successor, just successor, just successor 0, which isn't really what we want based off of how we've seen that Pinot numbers are constructed. So I find that when I come across these sorts of errors, I haven't broken down my problem far enough. So we want to make sure that we've actually constructed the natural number and that we've wrapped that value in a just if we actually had a natural number. So the way that I fixed this was creating a function locally. So that function is going to, the function f is going to actually construct the natural number, and then it's going to wrap that value in the just up there. So that was a way that I was able to solve that problem. So let's talk about our next problem here. Not enough arguments. So to set up this problem a little bit, the enumerate from to function takes 2 arguments of type A, and those types have to be enumerable, which is what that enum a fat arrow tells us. And for our problem, we're going to use the type ordering. As we see here, the type ordering has an instance of enumerable already, so we can use this type without having to write an enumerable type class instance. So here's how that works. Enumerate from to given less than, greater than is going to give you a list of less than, equal to, greater than, and enumerate from to greater than to less than is going to give you an empty list, just because that's backwards. And one of the functions that you can use to get the next value is the successor function. So given an A, you're going to get the next A. You could think of this like with integers, successor of 1 would be 2. And like successor of less than is equal to. So let's take a look at the function here of trying to implement this ourselves. So enum ord is going to take 2 arguments of ordering and give us back a list of ordering. And we're going to say that the beginning is B and the end is E. So if B is less than or equal to E, append B onto B's, and if it's not less than or equal to, return the empty list. And we're going to say that B's is equal to enum ord successor B. And let's look at the error that we get here. So we couldn't match the expected type list of ordering with the actual type that we provided, ordering to list of ordering. And it says the probable cause is that B's is applied to too few arguments. And it's pointing to the line that has B's here. So let's go look at that. It's pointing to then B cons B's. And we have our definition of that on the last line there. And so what did we say? What did we define B's to be? Well, the enum ord function takes 2 arguments, and right now we're only providing 1. So there are 2 ways that we can fix this. We can pass another argument in our definition there, which is my personal preference, or you can pass it to B's on the then line. So just like some background on this problem, personally, I felt pretty overwhelmed when I tried this for the first time several months ago. I wasn't familiar with the ordering type. It was strange how the enumeration of the data constructors for the ordering type worked. Still getting used to the cons operator to append an element to a list and returning empty list as a way to finish the recursion. It was my first time using the successor function. That's a lot of new stuff. So I didn't really focus on the logic of the function while I was trying to figure out how to piece all of this together. And so you may have noticed this actually blows up if you pass the last element of the ordering type twice, and it should return just like the list of greater than. So you can still get errors if you can still get runtime errors if you aren't careful about how you write your code. And so the way that I fixed this was, after my first attempt, understanding a little bit better about how the types and functions were working together, I was able to focus more on the logic. I found that the logic was easier to represent using a guard, writing out all the possibilities that I would need to cover for the problem. You know, if your code's more readable and it makes more sense to you, it's going to be easier to fix the errors you're getting. So we've talked a lot about how to think and feel a little bit better about error messages, as well as how to fix a bunch of them. But we haven't covered one thing. Getting good at debugging in any new language takes time. For Haskell specifically, I think it can be overwhelming as a beginner because there's so much new stuff you feel you need to learn to be good at it. I've gotten significantly better over the last year because I've practiced and I've written a lot of code. You don't necessarily need to know what exactly a function is doing in order to use it. You just need to find what fits and solves your problem. You'll learn stuff along the way. So if you read the error messages, like we've done today, and you use Google to look up the type signature you need, the functions, you can play around with it and get better at it, and you'll get better at fixing type errors. So thank you. And if you're interested in learning Haskell, if you've been inspired by this talk because you get all this type safety stuff and errors up front, I'll be running through Haskell Programming from First Principles by Chris Allen and Julie Muranoki. And I'll be running through it to the Monad chapter with Pierre starting on June 18th. So if you're interested, sign up link is there with all the details. Thank you.